I had this great question from a viewer. Is it possible for light to orbit a black hole? Consider this thought experiment, first explained by Newton. Imagine you had a cannon that could shoot a cannonball far away. The ball would fly downrange and then crash into the dirt. And if you shot the cannonball harder, it would fly further before slamming into the ground. And if you could shoot the cannonball hard enough and ignore air resistance, it would travel all the way around the Earth. The cannonball would be in orbit. It's falling towards the Earth, but the curvature of the Earth means that it's constantly falling just over the horizon. This works not only with cannonballs, astronauts, and satellites, but with light too. This was one of the big discoveries that Einstein made about the nature of gravity. Gravity isn't an attractive force between masses, it's actually a distortion of space-time. When light falls into the gravity well of a massive object, it bends to follow the curvature of space-time. Distant galaxies, the sun, and even our own Earth will cause light to be deflected from its path by the distortion of space-time. But it's the incredible gravity of black holes that can tie space-time into knots. And yes, there is a region around a black hole where even photons are forced to travel in an orbit. In fact, this region is known as the Photon Sphere. From far enough away, black holes act like any massive object. If you replace the sun with a black hole of the same mass, our Earth would continue to orbit in exactly the same way. But as you get closer and closer to the black hole, the orbiting object needs to go faster and faster as it whips around the massive object. The photon sphere is the final stable orbit that you can have around a black hole, and only light moving at, well, the speed of light can actually exist at this altitude. Imagine you could exist right at the photon sphere of a black hole, which you can't, so don't try. You could point your flashlight in one direction and see the light behind you after it had fully orbited the black hole. You would also be bathed in radiation of all the photons captured in this region. The visible light might be pretty, but the X-ray and gamma radiation would cook you like an oven. Below the photon sphere, you would see only darkness. Down there is the event horizon, light's point of no return. And up above, you'd see the universe distorted by the massive gravity of the black hole. You'd see the entire sky in view, even stars that would normally be obscured by the black hole as they warp around in its gravity. It would be an awesome and deadly place to be, but it would sure beat falling down below the event horizon. If you could get down into the photon sphere, what kind of experiments would you want to do? Tell us in the comments below. Thanks for watching. Never miss an episode by clicking subscribe right over here. Our Guide to Space series is made possible by the members of our Patreon community. We'd like to thank Lars Peter Hammer, Susie Berg, Steve Grzanich, and Jeff Tropiano, and the many others who contribute to our efforts to bring great space and astronomy content every month. If you want to see extra materials like behind-the-scenes content and full-length, raw interviews, you too can become a member of our community. Find out how by clicking here.
Give me a clap.
To put on my space gloves first.
Don't try and be fun just so you can get in the blooper reel.
I don't want to be in the
So
blooper reel.
contrived.
So contrived. You won't be able to resist the blooper reel. Just
Keep clapping.
Just keep clapping. Yay! Space. All right.
Ready?
Yep.
Excited?
I am excited.